So we're going to talk about parallel line theorems, which these are parallel lines going off into the distance there. We have a few different theorems. These ones I think are a little easier than some that you've done so far this unit. Let's talk first about the C pattern. We have talked about this one before. It's stating that the angles that are on the interior of a C pattern are supplementary. That means they add up to 180. So we've got two parallel lines here. And remember, we indicate that they're parallel with these little arrows here. So that means those are parallel. I'm going to draw a transversal through them. That's just a line cutting through them. And you're always drawing with a ruler. So the interior angles are the C pattern. I'm going to draw a C right here. Here's with my highlighter. Here is the letter C. So the C pattern, or the interior angle theorem, says that the angles on the inside, if I called this one, not the X, and this one were Y, then those two have to add up to be 180 degrees. They add up to 180. So X plus Y is 180. And we've done this one before. This one's kind of review for us. And of course, there is a C on the other side. There's a C. Let me take a different color here. Maybe this green will work. There's another C. It's backwards, but there's another C there. So the two angles that would be in this corner, maybe we'll call them A and B, they also add up to 180 degrees. A plus B is 180. The next one we're going to look at is the corresponding angles. That's an F pattern. So let's start with our two parallel lines, and we'll put arrows on them to show they're parallel. And we have a transversal going through them. Looking under the explanation, it says that the angles that are in the corners of an F pattern are equal. They have the same or corresponding position. So I will highlight that again. So let's find an F here. We're looking for an F. So here is an F. And the F pattern says that the angles that are kind of tucked into the corners of the F, so this angle and this angle, they're equal to each other if they're tucked into the corners like that. But there's another F here. Let's go with the green highlighter. We've got a backwards F right here. There's another F. So the angles tucked into the corner here, I'll use a different symbol. I won't use that same curve symbol. Maybe just an open circle there and an open circle there. So those are equal. There's more F's. There's two more. Do you see them? Let's try another highlighter color. Here's an upside down and backwards F right there. There's another one. So that one tells me that this angle right here, I'll just put an X here, this angle right here and this angle right here, these two, they're equal to each other because they are corresponding. And there's one more F pattern. This one is backwards and upside down, still using the transversal. And then here is the parallel part there. And that, again, same thing over and over again. So the angles tucked in the corners of the F, just put a colored dot there, a colored in dot there. Those two are equal to each other. So if you have a transversal with two parallel lines, you've got a whole bunch of angles that are equal to each other. The F pattern, the corresponding angle theorem, is really, really helpful. If you can find those F's in there, you'll get a whole bunch of answers. The next one is alternate angles. That's a Z pattern. So again, same thing. We're going to start with two parallel lines, and we're going to put, I'm just going to put my arrows the other way just to show you it doesn't matter which way you point them. Transversal. And now I'm going to draw a Z. Z, because we are Canadian, not Z. Okay, whoops. Let's draw the Z. It's like this. There's a Z. So the angles that are equal here are the ones tucked in the corners of the Z. They alternate. One's on this side, the other one's on this side. Those are alternating angles, and they're equal to each other. There is another Z. Just one more, not like the F had so many. There's a backwards one here, like this. So that one tells me that again, the angle's tucked into the corner. So if this one, we call this one A right here, then this one is also an A and they're equal to each other. That's the Z pattern. Next is the opposite angle theorem. This one isn't a parallel line theorem. This one is super useful though. I love this one. It's so easy. You don't have to do any math for it. It's just really straightforward. Look at the explanation. When two lines cross each other, not parallel, just two lines cross each other like this, the angles which are directly opposite each other are equal. That means this angle right here, if this is a W, then opposite the X. So it has to be an X that's formed. Those two are equal. So anytime you draw an X, it works. If I had another line coming, say, like through there, I couldn't say that this side here, where I'm putting a little curve, that little piece is equal to this piece because they're not formed by an X because we've got that extra piece. This whole side, though, that whole angle equals that whole angle. So just make sure it's an X and it's not like a K or something with an extra piece in it. But this is the opposite angle theorem. Is really, really easy and helpful. This is our only example. Determine the unknown measures for each question and, of course, justify your answers. So we have to explain where we're getting our answers from. Looking at A, part A, I mean, we've got two unknown measures here. We've got a B and an A, and we have to find the value of both of them. So what I like to do when I have these questions, especially if it's on a test or a quiz, I just would start by filling in everything I know. Even if I'm not getting A or B, I'm just going to write down. So you wouldn't write in your textbook, of course, but you could redraw this and put it on paper. Here's an X. See the X right here? That means this corner is also 60 degrees because it's opposite the other ones. That was the one I just showed you, so this is a really handy theorem. And once we know that that's a 60, we can also use our straight line, our supplementary angle theorem. These two have to add up to 180, remember? That's one of our first theorems from this unit. So that means that my other side here has got to be 120. Now the question's not asking me for those, but I'm going to put them in anyway. And that means up here we have 120 because they're opposite each other. So now that we have those, we wouldn't even ask for those ones, but fill in everything that we can. So let's go to some of our other theorems. I'd like to get to that letter B. So when I think about the letter B, I've got a backwards F here. These lines are parallel because of these arrows, so I know they're parallel. I've got a backwards F, and that means B, so I can put my answer down. I have an answer here. B is going to be 60 degrees. And my reason for that, how I got that, you can either write F pattern or you could write corresponding angles. Most students prefer to write. So I used F pattern for that. And I used opposite angle theorem. I used both of those to get that. So I now know that B is 60. Here's a 60 in here. The only other one I have to find now is A. Well, how am I going to get this A way over here? Okay, that A is part of a triangle. Anytime we have a part of a triangle, it's really helpful because we already have a whole bunch of triangle theorems. So think of this as a triangle. We've used our parallel lines now. I don't know if we can use them again with this A because there's no transversal going through the A here, so I can't really make a C or a Z pattern or anything there. So I'm going to instead look at it as a triangle. As a triangle, if I know all three angles, then I know they have to add up to 180 degrees. So what's this one up here going to be? Well, I have a straight line right here. I know that this corner is 60. So the angle that I'm looking for there, I can do 180 minus 60. And that will give me 120. So that gives me this corner up here. So now when I look at my three angles, I can finally get A because those three angles have to add up to 180 degrees. 45 plus 120 plus A has to equal 180 degrees, and that is my sum of the angles in a triangle theorem. Now I did also use the supplementary angle theorem, so I can label that up here. Supplementary angle theorem, or you could write straight line or something like that. Okay, now let's solve for A using a little bit of algebra, and we get A is equal to 15 degrees. So there's our final answers, A and B. Now over to question B. Again, I've got two transversals here, so I'm going to label a bunch of stuff. Even if I don't think I need it right now, I like to always use my X one. I find an X and then diagonally opposite, vertically opposite that one, I've got another 86. Here's another X. So this one's 141. I know that D and E are going to equal each other because they're opposite each other on an X. So let me erase that. So I've got a few numbers here that I may or may not need. That does help me with D though. So if you can see D, there are many ways to do this. Right now you might be thinking, oh, I was going to use a C pattern, then I was going to, well, actually let's use a C pattern here. Let's use a C pattern right here. Here's a backwards C right here. So the rule for the C pattern, which is also the interior angle theorem, says that those two have to add up to 180 degrees. So that means 141 plus H has to equal 180 degrees, and that's the C pattern. That's all you need to write there. C pat is good. So what is H? So you're going to subtract 141 from both sides to get H, and we get 39. So there's H, 39 degrees. There's 39 degrees right there. And that helps me get G, because G and H are right across a straight line from each other. These two are going to add up to 180 degrees. 39 plus G equals 180 degrees, and that's the supplementary angle theorem. So G is going to be 141. And I could have got that other ways too, and hopefully some of you are thinking of those other ways. Let me just show you what some of those other ways are. Go with the highlighter here. I had a F right here. Did you hope maybe somebody saw that F and you said, oh, well, G's 141, right, because of the F. Or maybe somebody else saw a Z right here, Z pattern right there. That puts G again at 141 because this angle and this angle are equal. So there's lots of ways to come up with the right answer. We just have to make sure we get all our letters. So we've got G and H so far. Now we need over here, we need our D, you need these ones here, D, E, and F. So let's go back over to this side. D, okay, D, there's an F pattern there. Do you see the F pattern that will get me D? Or you could use the Z pattern. The Z pattern will also get me D with the 86. Let me put that in, I'll use the Z. Here's the Z. That tells me that the angles tucked in the corners of the Z are equal to each other, so this corner and this corner are equal. That means D is 86 degrees, and that's because of the Z pattern. Now that I have D, I have E, because they're across from each other. They're directly across from each other where an X is. So E is the same as D. E equals D, so E is equal to 86 degrees, and that's because of the opposite angle theorem. All we have left is F, and I think you guys can probably figure out what F is. These two together have to add up to 180. I could think of it that way. I could also think of it the other way. These two have to add up to 180. It doesn't matter, we're going to get the same answer. F is equal to 94 degrees. And I used the supplementary angle theorem for that one. So we got all of our angles without, we had a little bit of math to do, a little bit of addition, but that's it. We were just really labeling ones. You get some more challenging ones in your homework that you're actually going to think about, but these ones are pretty straightforward here. Last one, part C. Okay, so I want you to press pause here and do this one yourself. See if you can come up with all of them. Label everything you know, even the ones that you don't think matter, like even this out here. This is the same as B. I'm using my X pattern first. That's a 115. That's a 55. That's an A. So just start labeling any angles that you know. Start labeling them all, and then come back and we'll do it together. Okay, if you're done, let's start with the easy one, I think is the A. For the A, I have a Z here. That tells me A is 55. Hopefully everybody got that. A is 55 degrees, and that was the Z pattern. And what else? So I can make that a 55 now. I know that's 55. And now let's work with, how about C? This is a straight line right here, which means these two add up to 180. Or you could have gone with the one above it, but that gives me C equals, so we're doing 180, subtract 115. C equals 65. And that was from the supplementary angle theorem. Okay, we're doing well. Let me erase this here. So we got C to be 65. Okay, now how about D? D is probably, oh, we have to get B and D still. Let's do B next. B, okay, let me get the highlighter out, and when I look at B, I can do, I could do lots of different patterns here. Maybe the easiest one is the F pattern. There's an F. So the angles tucked in the corners of the F are equal. That means that B is equal to 65 degrees from the F pattern. Now, did you get D on your own? It's the hardest one on this example. Were you able to get D on your own? D's a little challenging because it's not at one of the parallel lines, so I can't use those parallel line theorems. But I do have, remember what I, look over in example A, what I put a red shape around there is a triangle. Right here I have a triangle. Remember, we have lots of triangle theorems, but the main one is the interior angles of a triangle add up to 180 degrees. Now I know what this A is. It's opposite this A, right? That's why they're equal to each other. So that's a 55. We've got a 55 and a 65. So why am I even doing this? I'll tell you in a second. I want to get this little angle down here. Let's just call it X. X is equal to 180, subtract 65, subtract 55. And that's the sum of the angles in a triangle theorem. You could have written it out a different way, but that little X angle right there turns out to be 60. So did that help us? So this is a 60. I'm putting it in the little corner there. That's a 60. Does that help us get D? For sure it does. Absolutely it helps us get D, because here's a straight line. These two angles form a straight line. That means D plus 60 has to equal 180 degrees, and the reason for that is they're on a straight line, or the supplementary angle theorem. So that gives me D equals 120. And if you got all those on your own, congratulations. Those were all different little theorems you could use there. That's the lesson on the parallel line theorems, and it's fun to do these questions on your own, because sometimes once you start to see the patterns, they come really, really quickly. So it's a kind of a short lesson, 20 minutes. If you have any questions, let me know.